What we're going to do today is look at deploying cloud infrastructure on Azure with Massdriver. We're going to be deploying a 3-tiered web architecture running a simple Rails e-commerce API, and we're going to deploy it using Azure Kubernetes Service and talk through some of the security constraints and compliance that we apply to your Kubernetes clusters through Massdriver on Azure, as well as looking at deploying Postgres and Redis in a virtual network. So I'm going to go ahead and screen share. I've already kind of set up a base project in Massdriver. This is a Massdriver project canvas. So in Massdriver, you can manage cloud infrastructure on AWS, Azure, GCP, and Kubernetes bare metal clusters. You can see that I've got a number of projects here already set up. We're going to be working in this AKS in minutes project. But I wanted to talk briefly about the concept of a project in Massdriver. So these act as a replication and parity boundary for your cloud infrastructure. What that means is anything that you design inside of one of these projects can be replicated to different cloud environments and also to different regions or different customers of yours. They're fully isolated with independent cloud credentials, so you can have separate AWS or Azure subscriptions, and they have independent scale, so you can deploy through one canvas, a staging environment and a production environment with the applicable scale for each of those two environments. I'm going to go ahead and start by clicking on my AKS in minutes, but you could also create your own project by clicking Create Project. And what you'll see in here is that we've already set up 2 environments ahead of time. We have a production environment and a staging environment. I'm going to go ahead and hop here. And I've already done one thing in this, and that was deploying a network just so we could get started on this quickly. But I'll actually tear down this infrastructure and rebuild it as a part of walking through this so we can see how Massdriver makes it really easy to manage and configure infrastructure in the cloud. So first, I'm going to just go ahead and tear down these resources, and then we're going to add our application back on. I'll keep this network here. And so if you're following along, we have a Rails application that has already been published into Massdriver. So at the core of Massdriver is a package manager that can run and schedule cloud infrastructure and applications. So very similar in ideas to a package manager you might have in a programming language where it lets you define dependencies, except for instead of running code inside of your project, this actually runs the provisioning code to put this infrastructure in the cloud and then represent the current state of that infrastructure and application health back to you on the canvas. So I'm going to go ahead and filter our package manager by Azure here, and you'll see that there's a number of different resources that are available. What I'm going to look for, though, rather than going through and building stuff from the infrastructure up, I'm going to find my application, which I've also published into this package registry. So you can use public packages in Massdriver, or you also have your own private repository where you can publish infrastructure and applications. So I published an application earlier called Rails that we'll go ahead and drag onto this canvas, and I'm going to call this ecom. Go ahead and close out our sidebar. If you're following along, you'll also need to attach a security credential if you've already uploaded those. To attach a credential to your canvas, you can click on the cloud that you want to bind and then select the credential that you want to attach to this canvas. This will be used to provision every piece of infrastructure on this canvas. So I've already attached a credential there. So, networks are this thing that we always need in the cloud, whether you're in AWS, GCP, or Azure. It's one of the first things that you experience when you're deploying stuff. A lot of the clouds give you a default network. They're great, very easy to get started on, but there are a number of choices that they make in the configuration of those default networks that aren't necessarily secure, right? They're targeting the 80-20 use case, a network that kind of works for everybody. We've already configured this network here. We're going to come back to this network in a bit. We're actually going to start over on the application side. You can see there's this huge gap between what we want to run and where all this stuff actually physically runs. When we look at an application in Massdriver, there is this idea of dependencies, and these dependencies are very developer oriented. We're focusing on the fact that I need a Kubernetes cluster to run this application. This application also says that it needs Postgres and Redis. And you can see Massdriver is actually agnostic about how this gets scheduled. I could run Redis on GCP, or I could run it on Azure or AWS. All of these dependencies are specified in a Massdriver YAML file that you would put with your applications. This one is shared in the example repo, but You can just see this here. There's a lot of YAML in here, but nothing to be afraid of. This is where I've said my requirements for this application. So I said it needs to run on Kubernetes. It needs some sort of cloud authentication. It needs Postgres and Redis. So I'm effectively just listing out the dependencies my application has. What we'll also see in a little bit is this also controls your configuration, like your environment variables and your secrets as well. So we'll come back to this in a minute when we start configuring the secrets for our application. But for now, let's go ahead and start building some infrastructure. So if I wanted to add Kubernetes or a database, Mongo, et cetera, I could click on that sidebar, the little package icon over here, and start provisioning infrastructure. You can also highlight over any of these dependencies and select a recommendation from Massdriver. So I can select an AKS cluster, and maybe I'll call this cluster compute. What you'll see here is this idea of an abbreviation. So this is a naming convention that we're effectively creating hierarchically from your project to your environment production, now down to this actual set of resources that we're calling compute here. What this does is two things. It can naming convention on everything that is in your Kubernetes cluster, and it also configures tagging conventions as well. So a year or two down the line, when you want to start assigning costs for your cloud usage based off of project or environment, all those things are already tagged for you. Go ahead and add to Canvas, and we should see this Kubernetes cluster appear here. And you can see the Kubernetes cluster also needs a network. I can either add a new network, or I could select my existing network and it'll connect it. I'm going to do the same thing for Postgres. I'll grab a Postgres flexible server. I'll just call this DB. And I will, that appeared far away. Let me go ahead and zoom out. I'll connect this to my network as well. And you can drag and connect as well as using those recommendations. And I'll go ahead and take one more recommendation here for an Azure Redis cache. This is going to hold my user sessions. Okie doke. And I'll also connect this to the same network. So you can see here in just a matter of minutes, I was able to take dependencies that make sense from a developer point of view, Kubernetes, Postgres, and Redis, and start to generate actual cloud infrastructure to run this. Now, this hasn't been provisioned yet. You can see this blue icon right here. It means that we've kind of drawn out the infrastructure, but haven't configured it yet. If we also switch over real quick to our staging environment, what you'll also see is we got the exact same diagram here, but you'll see that I can configure alternate scale for these and provision them independently. So if I wanted to have a smaller network for staging or a smaller compute cluster for Kubernetes, I can do that. I'm going to switch back over to production, and we're going to go ahead and start deploying some of this stuff. And as we deploy it, it can take a minute for the provisioning to happen. Massdriver takes care of the state and provisioning for you. As it's going through this, we'll talk through some of the configuration that we put into these bundles, as well as some of the best practices that we put in place to make your infrastructure secure and compliant by default. So we'll go ahead, click on configure for this Kubernetes cluster. We have this concept in our package manager called configuration presets. So our package manager is IAC agnostic. Today it supports Terraform and Helm. You can also put in these ideas of presets. So this is really great if you have an operations team and you're trying to build really good configurations for your developers to self-serve. We do this in every bundle that we build in open source. We give a development and a production preset. You can come in here, you can select development. It's going to give you a pretty good configuration for a development environment. But you also see that you have full control over this infrastructure. So if you've never deployed Kubernetes before, but you just need to get something up and running, you can grab a preset. You can come in and fine tune it when you learn a bit more about how your workload works. I'm going to check two things off here. I'm going to check enable ingress controller. This is going to give my Kubernetes the ability to create load balancers and route traffic directly to my applications. And I'm also going to associate a DNS zone. I have a DNS zone called Massdriver Azure Sandbox that I've already set up with Massdriver. This will give my Kubernetes cluster the ability to do a couple of things. A, checking the ingress box lets us route traffic in. By enabling this DNS zone, two things happen. External DNS will be installed and configured on the cluster. This allows you to declaratively say that you want host names in your different application services, and Kubernetes will take care of all the DNS registration for that for you behind the scenes. This also configures Let's Encrypt to make sure that you have SSL certificates for each of the applications that you expose and that those are kept up to date. So I'll go ahead and select that here. If you're following along, you'll need to select the domain name that you own and have configured with Azure DNS. And I'll click deploy. And what you'll see here is the provisioning for this Kubernetes cluster is started. So Massdriver does all the provisioning and the state storage, very similar to something like Terraform Cloud or Spacelift, without having to configure any additional CI/CD. We didn't go into a Git account. Everything is currently being managed right here. Now, what's interesting about this is if you don't have a ton of infrastructure experience today and you want to use a GUI to manage your infrastructure, great way to do it. If 2 or 3 years down the line, you have an operations team and they really want to move some of the company to GitOps, we support a GitOps model as well. So everything in Massdriver is API first using a GraphQL API. We have a CLI tool as well that you can include in GitLab, Azure DevOps, or GitHub Actions to automate the configuration of your infrastructure. So you can come in here, draw some stuff, but then use pull requests to effectively configure infrastructure as you merge. So we'll go ahead and let this start to run. We'll go ahead and start Postgres and Redis. I'm just going to select the development configurations so we can get through those pretty quickly and move on to our application. While all this stuff's provisioning, we'll walk through some of the different things that we add to Azure and Azure Kubernetes clusters at Postgres and Redis. So I'll go in here. I'm going to select development. You can see that there's a number of configuration options that are available here. I'm going to go ahead. There we go. I'm going to set a username. I'm just going to call this my Spree Store admin. One thing I'll point out here real quick as we pass by it is this automatic CIDR selection. So on my network, I have this same option. And this is a really great feature if you don't have a ton of experience managing CIDRs and subnets. CIDRs and subnets are kind of all over the place in the cloud, from node pools to instances to networks. And making a mistake in picking your CIDR range can be very costly to you down the line. A lot of the clouds give you a very big IP space by default. These are great. They're hard to mess up until you need to peer something down the line. And so what Massdriver's automatic CIDR selection does is it looks at the size of the IP pool that you want rather than making you pick a CIDR range. And then it scans the cloud to see what CIDRs you're already using in different subnets or networks. And it picks a CIDR range that will be non-conflicting with the rest of your networks. That's just the right size for the IP pool that you're trying to run. What this allows you to do is kind of not think about CIDR selection at all without getting to yourself or getting to the place where you aren't able to peer your networks in the future. Another thing you'll see down here is this automated mode for monitoring. And so by default, a lot of our infrastructure bundles, we're starting to roll these out everywhere, have an automated mode for metrics, monitors, and alerts. So if you manage infrastructure in Massdriver, we have an alerting system similar to PagerDuty. If anything's experiencing issues, maybe a Redis instance is running out of RAM or a Postgres is sitting at 95% CPU utilization, you'll get an email. If you click on that email, it'll take you to your actual piece of infrastructure in Massdriver. Once this is provisioned, you'll see a little cloud right there. It'll be red if there's an issue. And when you click on that, you'll be able to see the real-time health of your infrastructure. So the goal is not just to be able to provision infrastructure, but allow engineers to quickly understand the health of their infrastructure and then remediate any problems. And we'll look at a couple of other tools that we have in place to do that in just a moment. I'm going to go ahead and just kind of speed run through Redis here. I'm going to select the development version, and I'm going to keep it in automated mode for monitoring, hit deploy. And then while those are provisioning, we got to wait for those to provision before we can schedule our application. I'm going to talk through some of the stuff that we put inside of these different bundles that we build. So again, everything that you see in Massdriver is extendable. We build a number of bundles, but you can publish your own. You can also see that we open source all the bundles that we build. So if you aren't a Massdriver customer and you just want to use really good Terraform modules for managing your cloud infrastructure, these are just Terraform under the hood. If we hop over here, you can see that this is just a regular Terraform module that you can come in, fork this, make modifications to it, publish it to the Terraform registry or to the Massdriver registry, and be able to provision infrastructure. One second, I just want to make sure that there are no questions. Okay, that I'm missing right now. Sorry, I'm in full screen on a small laptop. Okie dokie. Don't see anything. Okay. Cool. So we'll go ahead and look through a couple of these real quick. One of the first things to note is that we actually do a lot of work to make sure that the infrastructure that are in the bundles or modules that we open source is secure and compliant by default. So we strive for CIS, PCI, NIST, ISO, SOC 2, in HIPAA compliance by default for everything that we ship. We will register a bug or an issue in GitHub as something that we need to fix if any of these fall out of compliance. So you get a good base level of compliance and security using the bundles that we develop, whether you use Massdriver or if you're just using them in your own Terraform modules. Now, when we actually go and look through some of these, we'll start with the networking here. So you can see that we've got this Kubernetes cluster. We'll open that one up, and we'll also open up our VNet. There we go. Sorry, small laptop. There we go. Okie doke. So you can see in here, there's just some typical Terraform. There's slight differences with or an additional provider you need to use when you're integrating with Massdriver that we'll see here in this artifacts file. But for the most part, this is just plain vanilla Terraform. If we click on main here, you'll see that this is just a typical Azure virtual network that we're provisioning. So a couple of notes here on our virtual networks. We use private link by default. And the goal here is to make sure that all the communications between all your services on your VNet are secure. Again, we go through SOC 2, HIPAA, ISO, NIST, PCI. We also create a default subnet as a part of this to make sure there's a subnet for your compute to land on. And we reserve half of the subnet space for Azure services that require subnets. So when you're deploying things like Postgres and Redis, they need their own subnets to operate within. So we make plenty of room for those. If you look at this Kubernetes cluster here, you'll see again, we've gone through all the CIS, PCI, NIST, et cetera, to get these to a nice, compliant, secure place to start from. And it's very similar. What you'll see here is we actually add a couple of other things, including some core services and some custom resources. So a lot of the work that we do in these Kubernetes modules are to make sure that you get really good Kubernetes configurations by default. While Massdriver works for all things cloud, whether these are app functions or Databricks integration with Azure, when it comes to Kubernetes, it really is kind of its own cloud, and it can be pretty complicated to configure if you don't have a ton of experience. So we try to get a lot of the really good resources that people need in there by default configured well. So external DNS, Let's Encrypt, et cetera. Some of the other things we do with our Kubernetes clusters, sorry, give me 1 second here. I've got a little bit of lag on my side. Let me just check with team to make sure that everything's coming through okay. Just want to make sure I haven't lost anybody. My lagging a bit over here. Okay, cool. Everybody said it sounds good, looks good. Okay, sorry about that. I was just kind of grinding to a halt over here in Zoom. So in the Kubernetes clusters, we provision everything into private subnets by default. And again, we try to take a pretty hard security stance and compliance stance on all the bundles that we build. If you want to derive from that, you are free to fork and republish the bundles in Massdriver or use those modules on your own. But all of the node groups that we create deploy into a private subnet. The goal there is to make sure these aren't exposed to the internet by default. We can use load balancers to route traffic into them. We also create an identity with principle of least privilege for managing your DNS zones. So this allows you to just simply select that DNS zone like we saw on the dropdown earlier and have all of your applications be able to say what host names they need in a very declarative manner. Here we use Azure's CNI for networking instead of the KubeNet. This allows all of your applications to use node IP addresses. And we also install server and kube state metrics by default for pulling metrics of your actual cluster. I'm going to go back and just check real quick to see if our databases are coming along. Okay, it looks like our Kubernetes cluster is up, but it looks like Redis and Postgres are still provisioning. We'll go ahead and we'll just take a look at something real quick here. So when we see on this Spree application that we're going to be deploying here in a minute, there are a couple of buttons that are available. One, we see that there's this notification on the secrets. So Massdriver also supports secrets management. What's really interesting here is when you click on this, you can see that my application says that it needs an admin email, it needs a password, and it needs a secret key base. So if you're following along, we can go ahead and put in some data here. All of the secrets in Massdriver are stored in an air-gapped VPC using per row encryption. So you get really good high-level security for storing all of your application secrets. I'm going to go ahead and type in a real silly password here that everybody can see while I'm typing it, and then it's locked away in a vault. And then we'll also add a secret key base. If you're following along, you can kind of type in anything you want here. This is just a configuration parameter for Rails applications for how they secure some of their cookies and other secrets. So you can see here that the number of secrets that this application required was fairly low, and it was very oriented towards this Rails application. What we didn't see here was database URL or Redis URL. And the reason why is Massdriver takes care of all of your infrastructure secrets by default. The only secrets you actually have to list are the ones that your application needs, not that you need from your infrastructure, effectively third-party secrets. The lines in Massdriver, you can see this line is solidified from Postgres into this port over here, saying that it needs Postgres. Once that's provisioned, Massdriver will inject the credentials for Postgres directly into the runtime of your application. You don't have to set up HashiCorp Vault or any sort of secret manager in the cloud. You don't have to use LastPass or copy and paste passwords around. By drawing a line between your infrastructure and your applications, the credentials are automatically injected. Similarly, the same thing will happen for Redis. And when drawing lines between applications and compute targets, like let's say Nomad or Kubernetes, it configures your CI/CD target. So this line here is telling this application when it provisions to schedule the containers on this Kubernetes cluster. We're gonna have to wait just a few more minutes here for this Redis to come up. But in the meantime, I want to show you a couple other pieces of functionality that are in Massdriver. So we have this concept of guides. And what these guides do is they have a lot of information, particularly in bundles that we develop, on best practices that we've followed, some of the presets, details on those, and then design decisions and caveats of what we've built. Our goal here is to kind of share our design doc for any piece of infrastructure we're developing with our customers and with the open source community, just so we can increase the knowledge of software developers as far as how the cloud and different resources operate. What's cool with this is if you're building your own resources for Massdriver or your own applications, you can treat this guide kind of as a runbook. And so you can see here on this Rails application that we're using as a part of the demo, I've got a runbook for, in this example, it's how to connect to a running pod in Kubernetes, and then some Ruby commands that I can run to populate this database with some example information. So we'll be running these here in just a little bit to populate our e-commerce store. Another thing I want to show while this is provisioning is the resource inventory. So you'll see here while this is running, let me zoom in just a little bit. You can see that this says progress. If we click on this, it's going to show you the current provisioning state of this piece of infrastructure. Once it's finished provisioning, what you'll end up with is this resources tab. And this resources tab tracks all of the resources that are actually inside of this concept that we're calling Kubernetes, right? We have this high level box that makes sense on a whiteboard. It makes sense to a software developer, but in reality, there's a ton of different cloud resources as well as compute and configuration inside of this bundle. And so this is a way of being able to see everything that's inside of here in one pane of glass. The other option, or the other things that we have here, is this history, and this history is pretty cool. I'm going to go ahead and you can see that I've got some metrics coming in here for my Postgres instance. What I'm going to do is I'm going to disable these metrics and monitors. So if I click on configure, I can come in here and maybe let's change a couple of things. Let's change the backup to 15 days, and I'm going to disable monitors and alarms. So you can see the other option here is customize. So you can either put your alarms and monitors in automated mode. We'll look at your current configuration and generate some pretty good alarms by default. You can switch to custom and fine tune them, or you can disable them if it's a development or preview environment. Okay, and I'll go ahead and hit deploy, and then I'll start provisioning. So what I want to show you here is the ability to use our history tab to see differences in your infrastructure. So you can see here that there's a deployment that's currently running. If I click on this plus symbol, I can take any 2 points in time. So I'll take the provisioning time earlier today when I first created this cluster and right now, and I can click compare. And what you'll see in here is there's some values that are going to be highlighted in red. That is one of the values that I just changed. You can also see the monitoring mode went from automated to disabled. So the goal here is to make it really easy for you to spot configuration changes that have happened in your infrastructure. One of the concerns in empowering developers to kind of manage this themselves in a self-serve environment is not having any sort of audit trail of what has changed. This is a really great way to allow people to configure what they need. And then if somebody's offline during an outage, I can come in here and see essentially a history of every single change that's ever happened. So if somebody changed something at 5 p.m., 2 a.m., Redis goes down, I can come in here and see that maybe somebody removed a replica or scaled down the memory or maybe change the instance size. I can change it back, hit deploy, and hopefully get back into a good state pretty quickly. Okay. Let's just see where we are here on this Redis instance. Looks like Redis is still going. I'm going to refresh just in case that's some UI lag. It looks like Redis is still going. Okie dokie. Okie doke. Cool. So while we're waiting on that, are there any questions in the any questions? No questions right now. Okie doke. Well, what we'll go ahead and do is while that's provisioning, we'll go ahead and take a look at a couple other features. So as I mentioned earlier, there is this concept of environments. So one of the things that's really hard in the cloud is managing parity, right? So if you're really invested in infrastructure as code, it can be easy to use something like Terraform workspaces to create multiple versions of your infrastructure. Massdriver has this concept of environments that also give you a very similar functionality. It lets you design something once and then be able to provision this multiple times in different environments and regions. So you can see here that we've got this staging environment. I can use this cloning functionality. Maybe I want to add a Core dev environment. Maybe I'm trying to completely spin up a replica of all of my infrastructure to maybe test a change to a network. I want to bring up an entire replica of this thing, make one change, see how it affects everything, tear it down. I can also have staging environments. If you're using our CLI tool, there's also a way of spinning up preview environments for all infrastructure. So it's not just spinning up clones of an application in a Kubernetes namespace. It will actually take everything on your canvas and replicate it. Queues, databases, networks, whatever you want on your canvas gets replicated to different preview environments. So this example that we're looking at here is a very kitchen sink example. We've got networks and compute clusters all on one canvas. You probably wouldn't actually want to replicate that stuff in a preview environment. Massdriver also supports the idea of essentially horizontally splitting your projects. You can make a base level infrastructure project that maybe you have for staging that you're sharing across a number of preview environments. And then you can have a dedicated shared production infrastructure project where your production infrastructure is. On top of both of those, you can layer application projects. That allows you to have really fast, ephemeral preview environments spin up for your applications while maximizing your compute utilization under the hood of that staging or production environment. So we're going to go ahead and here and do is we're going to configure some resources. We might not deploy everything just so we don't have to wait for it, but we can go ahead and just configure and save some of these. So I'm going to go ahead and we'll go ahead and select maybe 4,000 IP addresses for this staging environment. For this Redis instance, I'll grab a development configuration like I did in our other environment, but I'm going to maybe disable monitoring. And then for Kubernetes, I'm going to do the same thing. I'm going to select development, maybe change this size here to 5. And I know I'm kind of running through this. The goal is not to see how to configure all of these again. It's just so we can get a different configuration for staging versus production. Then I'll also do something very similar for this Postgres instance. We'll select a different instance type here, maybe something really big. I'll set the root name to admin, and then we'll hit save. So similarly to how we used the comparison tool earlier to look at different configurations over time, you can use the comparison tool to look at entire environments. So I can click on this plus or minus here. I can select my staging environment and I can select my production environment. I can hit compare and I can see all of the values that are different across this entire these entire environments. So you can see here, what it's showing me is just the stuff that's different. There's a lot of configuration options across all 5 of these pieces of infrastructure and application. Massdriver is simply showing me what's different. It looks like I actually didn't save when I was in Postgres here, but let me go back over here really quick. There we go. There we go. I probably didn't set a name. Oh, never mind. Picking a name you can't use. So that's actually pretty interesting that we got that validation error there. So this is one of the things that's really nice about this user interface. So this is a configuration interface on top of Helm and Terraform and other IAC tools that lets you express their very vague configurations in rich ways. So what you saw there was I got a validation error that the name that I was using, root, would not work for this database. So Azure doesn't allow you to use root. So rather than me provisioning that, opening a PR, starting a deployment, and then it failing 10 minutes later, Massdriver is able to detect that name is not valid and stop it before we've ever started to provision, before a PR is ever opened. So with our configuration interface, that same YAML file that we saw for applications earlier, you can do things like give nice names to the variable fields in Terraform or Helm, as well as descriptions. You can specify enumerations here, like we're doing with these different instance types, as well as validations, minimums, maximums, regexes, a pretty expressive set of validation rules to make sure that you're getting really good configurations before pushing them up to the cloud. So I'll go ahead and save here, and then I'll come back to this diffing. And what we should see here is there will be a number of differences. Maybe I didn't hit save again there. Okay, not sure what's happening there, but you can see the things that are different are being highlighted. So the goal is to be able to show you what's the difference between staging and production. Maybe you have a different node pool size or memory size in staging versus production. Staging's working really well, but production's faltering. Maybe you didn't turn on your replicas for Redis in production yet. So the goal is to be able to give you a snapshot, not just of how your configuration's changed over time, but how your configuration varies between different running environments. Okie doke, let's see if that Redis instance has finished provisioning yet. There we go. Cool. And if we go ahead and click here, you can see that we're starting to get some CPU memory usage and server load from this Redis instance. This is all handled for me. So I left this in automated mode. Not only is it sending the metrics back, but it's also configured some alarms as well. And you can see that I've now disabled this mode earlier when I was showing that we can disable it. So you can see the metrics are off now for Postgres. So now we're ready to deploy our application. We've already set some secrets here. We've got auto-routed secrets coming in from Massdriver by drawing these lines. Some of the other stuff that we do behind the scenes is automated IAM. So if we were connecting some serverless resources, maybe Azure Blob Storage or some functions, the IAM behind the scenes is also automatically created for you. So each application will get an identity in the cloud, and then that identity will be bound to the different policies, read and write policies to a blob store, maybe the ability to execute a serverless function, et cetera. So go ahead and configure here. And what we're going to go ahead and do is, this is a public Docker Hub image that you can run, Massdriver Cloud /Rails Spree. I'll drop this in the chat real quick. If you are following along, you can also do a Docker push and push your own image up from that repository. This one's a pretty good one to use, get going quickly. I'm going to go ahead and select a few values here. I'm going to set my database name. So what's going to happen when this spins up is it's going to connect to that Postgres database. It's going to initialize the database and load it with a bunch of data. So I'm just saying that my database name is ecom. And then down here, I'm going to do a couple of things. So the interaction between Kubernetes and your application and Massdriver, we know about both sides of this. So it allows us to do some interesting configuration stuff. When we enabled ingress earlier, this installed tooling in place to manage certificates, manage the host names, and also create load balancers routing traffic to our applications. By checking this box here, I'm actually allowing public traffic to come into my private subnet and route into the pods that are served behind this application. I can also specify a host name. I'm going to go ahead and do, I don't know how many of these ecoms I have, so I'm going to call this ecom 28th, since March 28th. If you are doing microservices and you have different paths that you want to route a single domain to, maybe you have 10 different services, you have one domain name, you can actually do path-based routing here as well. We'll leave this blank, route everything to this application. And I'm also going to go ahead and set it to 256 megs of RAM. So you can also use this to enable horizontal pod auto scaling and some other functionality as well in Kubernetes, but I'm just going to go ahead and go with this configuration. Let me just take one last look at it. That looks pretty good, and hit deploy. And so what this is now doing is, when we published this application earlier, which we can hop over and do, we can take a look at that here in just a second. When you publish an application in Massdriver, what you're actually doing is you're giving us some metadata about your application. Massdriver never gets access to your application's source code. It gets information about what your application's dependencies are, what secrets it needs, and how it can route values into your environment variables. From there, when you're publishing, it's just IAC for provisioning your infrastructure. So we can see here, it's creating an identity for our application. It's starting to use Helm, since it sees it's connected to Kubernetes, to install this into Kubernetes. And what should happen in a few minutes is we should get a DNS name, as well as a TLS certificate created so that we can start routing traffic to this, and we'll be able to go and see this application. While that's happening, what I want to do is take a quick look at this application's Massdriver YAML file and just highlight a few of the things that this is doing for us behind the scenes. So go ahead and share this URL. This is in the deploy directory, and this massdriver.yaml file. So I'll share this here in the chat. So you can see here is this is a pretty long YAML file, but this does a lot of stuff. This gives you full control over the UI for your application. So just like for bundles, you can configure the user interface, validations, enumerations, descriptions in the Massdriver UI. You can do the same thing for your applications. Think of it as a really nice typed way of interfacing with your environment variables. You can see here that I've got a number of environment variables that I'm setting behind the scenes. So we didn't set those in those secrets. This is actually determined at deploy time by Massdriver, and Massdriver will route values into each of these environment variables. The syntax here is using JQ expressions to essentially traverse your diagram and pull values out of your infrastructure. So this is pulling the username out of this Postgres configuration that we have access to. You can see here the keys or the secrets that we saw in the UI earlier, the admin email, the admin password. This is where I was able to say that these are required or not, and to show them in the UI so that we can track third-party secrets as well. And if I was using any sort of cloud infrastructure that had IAM policies, I could select the policies here. In this example, we're selecting the subscribe policy from a queue. So if your application needed some sort of access to a queue, whether it's push or whether it's publish or subscribe, you could say, when that queue is connected, give me the subscribe policy, and Massdriver will take care of creating the role and creating the policy bindings to make sure you have principal of least privilege to perform that action. Some of the other stuff here, there's a lot of stuff in here. This is all JSON schema, OpenAPI v3, saying the different fields that we want to expose in the UI and the different validation rules that are there. The YAML that you get by default is pretty good for most applications, but you can fine tune this and make the UI work however you need it to work for your team. So you can add fields, you can hide fields, you can limit the values that are in different enumerations. I just want to check for questions real quick. Any open questions? Does not look like it. Okie doke. So let's go ahead and see if this application is finished provisioning yet. Okay, it says it has. Hopefully DNS is propagated. Let me go down here and grab this name, ecom. And then this is just a minor detail, but this Rails application that we're running exposes its only interface on /admin. So I'm visiting /admin. So what we'll notice is I put in a username and password earlier. If I log into this, it's going to fail. And the reason why is I've set those values, but there's some scripts that I need to run in a Kubernetes pod to actually connect and provision this or populate this database with seed data. So I will go ahead and switch my screen share to a terminal, and then we're going to use the runbook that we have in the UI right here to connect to that Kubernetes pod and run some of these commands so we can actually see the data populate. So I'm just going to stop my screen share for 1 second to switch over to a terminal. Actually, let me show one more thing in there because anybody who's following along will need to do this. So you can also access credentials from Massdriver. So we're connecting to this Kubernetes cluster to run these commands. So you'll need to have the kubectl CLI tool, but you'll also need credentials to be able to attach this Kubernetes cluster. If you mouse over the output here, what you'll see is some metadata about the resource that was created by Massdriver. We can see that there is this artifact that came out of this, which is Kubernetes credentials. It's of the type Massdriver/Kubernetes cluster. So just little details here. Everything about Massdriver can be customized. So when we see Massdriver/Kubernetes cluster, this is our public open source type definition of what a Kubernetes cluster looks like. What's really cool with this is not only can you change the boxes in Massdriver, you can actually change the type system as well. This allows you to add your own clouds, as well as add your own type definitions for your application services or cloud services that may not be in the Massdriver package manager yet. I'm going to switch this to a kube config and click this, and this will download my Kubernetes config. This is going to allow me to exec into one of these pods and run the commands that I have here. Okie doke. So this is the fun part where people get to watch me fumble through typing things in my terminal. Okay. Okie doke. Everybody can see my terminal okay. Okie doke. So I'm going to do kubectl, kube config, and oh, I got 2 of them. Hold on a second. Let me re-download this really quick. I'm not sure which one I need. That's the one I'm looking for. Okay. Okie doke. Okie doke. So we can see a couple of things in here. So I just ran kubectl get pods using this credential is just downloaded. We can see 2 things here. So we can see this first pod that's sitting in this completed state. This is my database migration tool in Rails. So we're using Active Record to manage our database migration. So what happened was, as a part of this Helm chart, it's able to see that there is database migrations that need to run. And so it places a Kubernetes job to do these migrations as the deployment happens. So they effectively happen in parallel while this application is rolling out. And then we can see that there's a single pod here that's running, that's bound to the DNS name or the host name that we saw earlier that I was able to visit. This one's actually up and running my Rails application. So I'm going to go ahead and exec into this one. So the easiest way to do this, if you haven't done a kubectl get pods and seen the pod name, there's a standard naming convention in Massdriver for all the resources. We saw this earlier with the abbreviation where we saw when we were adding compute earlier, we saw that it was AIM for Azure Minutes, the project that I'm in, production, compute. You get the same naming convention for your applications. And you can see this here. I named this API ecom. So every resource in this Kubernetes cluster and in the cloud that is tied to this application, whether it's an IAM role or whether it's a Kubernetes pod, is going to have this same exact naming convention. So in Massdriver, if you mouse over the node, you'll actually see that naming convention appear. So if you haven't done this kubectl get, you can still get the name directly from Massdriver. Since I'm already sitting here, I'm just going to exec into this pod specifically. Okie doke. It looks like I'm sitting here. And then the 2 commands I need to run were break db seed to make the database. And I believe takes a little bit. And we'll run this one. And while that is running, we should be able to log into the UI now. So I'll go ahead and switch back to my browser. And hopefully I remember my password, because I can't see it anymore through the Massdriver UI because we store them so securely. I'm pretty sure it was just password, but we'll see. There we go. Cool. So now we are logged into this Spree e-commerce API. And so you can go in here and you can see that this application that we've just provisioned in just a matter of minutes by connecting the infrastructure, selecting a bunch of development presets and hitting deploy, has a TLS certificate, has received a domain name. We're able to connect to all of this infrastructure, whether it's Redis, Postgres, or Kubernetes. All of the DevOps has been kind of taken care of that for me, and I can just focus on my application. I say I need Kubernetes, DevOps, or sorry, Kubernetes, Postgres, and Redis, connect them, deploy, and you can see that it's populated my database now with all this different e-commerce products that my customers can buy. So that's the platform in a nutshell. As I mentioned earlier, all of our bundles are open source. So whether you're a Massdriver customer or not, if you're looking for really great Azure infrastructure and you're not finding a ton of resources in the Terraform registry, our bundles are a great place to get started. If you are interested in using Massdriver, all the attendees get a $5,000 credit for Massdriver. So make sure to follow up with us if you're interested in how to apply that. That's it. Thanks so much for your time.